In this video, I'm going to show you how to write a very basic collector, and we will try to collect the data into array list. As you know, collector is a terminal operation, and in order to get all the data from stream, we need to implement a collector interface, and that is what we will do. Let's say we will implement a collector called as array list collector, and the class is named array list collector impl of some type t implements collector interface. Collector interface takes three type arguments t, a and r. Let us assume the fact that t will be some type t. We don't know what data will come in. Accumulator will be of type list of integer, and result also will be of type list of integer. We need to understand what is accumulator and what is result, and while going ahead in this video I will explain you what that means in terms of array list collector. Let us implement all the methods. Now first of all, we have to provide a supplier, which is a mutable result container, and the supplier will be a new array list, because that is the mutable result container and array list. This is how you can write it in Lambda, but you can also write it in method reference array list : new. This is about supplier. Let's take a look at accumulator. In accumulator, what we get input as list of integer, and we get type t. This is not correct. This should be type t, and this should also be type t, and I will change this integer into type t. Now we have to accept list and type t. For example, like this, list and type t, or it can be some value, and list dot add. We are getting the mutable result container along with the value, and we are adding that value into the mutable result container, and it is represented by consumer interface. You can also change this to method reference using list add. Let's take a look at combine. Combiner will only be used if we are doing parallel stream. Right now we are not doing the parallel stream, but the implementation can look like this. You will get two mutable result container, left and right, and you can say left dot add all right and return left. In previous video I showed you how the combiner really works, where it will contain data in different mutable result container, and all the result container will be merged. That is the job of combiner. Finisher method is simple. We know that our mutable result container is of type list, and return type will also be the list. We can just say that I maps to I, which is an identity function, and unchecked cast can be done based on that. But you can write I arrow I. This is Lambda expression, but you can also do like this, function dot identity, and it does the same thing, t arrow t. It returns the same thing. It is an identity function. That is all on finisher. This will work only if no finishing. This particular code will work only if no finishing action is required, because we know that array list is the mutable result container and output will also be array list. But let's say that your input was immutable set builder, then you in finisher you have to write something dot build to finish the function. Let me show you an example for that. So let us take a look at two immutable list. This is a private static final object, and build is a method which is a finisher action. So it builds that particular object. That is what immutable list builder is. Google Guava has provided this finisher action that we are not going to provide, because we know for the fact that this array list doesn't need any form of finisher. Let's take a look at characteristics. In characteristics, we can just say we have to return a set. We can just say that enum set dot of characteristics dot identity finish. The reason behind that is we know that this function dot identity, that is unchecked cast, will work just fine. And that is all on writing our first collector. You don't have to write this collector to push your code to production. This is already provided in collectors class, and we will see all those things later on, but this is how it is. In next video, I will show you how to use this collector, and we will also write unit test to prove that this particular collector works.